Abstract class. A class that describes a category or set of objects but never includes individual objects or instances. A class that exists so subclasses can inherit from it. Examples. An account class could be an abstract class which cannot be directly instantiated. It must be either a checking account or savings account, both of which add attributes specific to their type to the basic attributes inherited from account. Context. Abstract classes are useful when building a model to where there is complete specialization of a domain class. That is, when all instances of superclass must be an instance of one of its subclasses. Activity diagram describes user, or system, activities, the person who does each activity, and the sequential flow of the activities. Swim lanes. Examples. The series of activities beginning from when a customer places an order through to its fulfillment across all departments. Context. Used to illustrate workflows comprising a series of activities, decisions, their synchronicity, and the actors involved. Contributes to the documentation of business processes used in the analysis phase of the SDLC. Diagram. Adaptive/predictive approach to SDLC. Predictive, an approach that assumes the project can be planned in advance and that the new information system can be developed according to that plan. Good for well understood and defined systems. Waterfall model. Adaptive, approach that assumes the project must be more flexible and adapt to changing needs as the project progresses. Uncertain needs. Higher risk. Examples. The waterfall model is an example of a predictive approach, where later stages rely on exhaustive work from earlier stages. The spiral model is an example of an adaptive approach that cycles over and over through development activities until the system is complete. Context. The SDLC provides a way to think about the development of a new system as a progressive process. Because it's difficult to find a single, comprehensive classification system, we place various approaches along a spectrum from adaptive to predictive. Diagram. Alpha/beta versions. Alpha, latest version that is incomplete but ready for some level of rigorous integration or usability. Testing. Short lifetime. Beta test version that is stable enough to be tested by end users over an extended period of time. Weeks or months. Next comes release version or production version. Examples. Gmail was famously in a beta stage for 5 years, at first requiring an invitation to use the service. Context. Alpha and beta test versions allow software developers to have real users interact with the product, which can help to identify problems before releasing a production version. In some cases, the software is used for real work, providing excellent insight into how the software will behave once it's released. Client-server architecture. A computer network configuration with users' computers and central computers that provide common services. Examples. The web is an example of client-server architecture. The client side, with web browsers on users' computers, relies on services provided by a web server such as Apache HTTP or Microsoft IIS. Context. Client-server architecture stands in contrast to stand-alone software systems, which execute on a single computer system. One advantage to client-server architecture is that it encourages software to be developed by using an application program 3-layer architecture, separating the view layer, the domain layer, and the data layer. Component diagram. Type of implementation diagram that shows the overall system architecture and the logical components within it. Identifies the logical, reusable, and transportable system components that define the system architecture. Examples. A diagram showing how a browser communicates over the Internet with a web server, and DAO. That web server communicates with an application server where business logic is stored, and a database server where data is stored. Context. The overall system architecture provides the context in which other design activities take place. Component diagrams allow designers to limit the problem scope to specific components of a solution. Diagram. Communication diagram. Type of interaction diagram that emphasizes the objects that send and receive messages for specific use case. Contains same info as sequence diagram but displays it differently. Examples. A whiteboard sketch of the objects involved in adding an item to an online shopping cart. Lines drawn between the objects indicate messages and their order is determined by their numbering. Context. Compared to sequence diagrams, communication diagrams emphasize coupling. They're also easier to sketch design ideas in a meeting, as they are easier to change and rearrange on the fly. Figure. DataAccess class. A class that is used to retrieve and send data to a database. Implement the bridge between data stored in program objects and in the relational database. Examples. A customer entity object, domain class, is sent a find customer, ACCTNO, message. It uses the ACCTNO to send a message to the customer DataAccess class to read the customer record from the database in order to initialize its own values before returning a new instance. Context. Rather than insert database access logic, including SQL statements, into the entity class. Methods. A separate layer of classes to access the database is often included in the design. Database normalization. Formal technique for evaluating and improving the quality of a relational database schema. Determines whether a database schema is flexible and whether it contains any wrong kinds of redundancy. 3 restrictions that can be applied to normalize a database. First, normal form, 1NF, second, normal form, 2NF, third, normal form, 3NF. Examples. Converting to 1NF means removing any repeating groups from the data so that all rows have the same number of columns. Converting to 2NF means making sure each non-key attribute is functionally dependent on the entire primary key. Converting to 3NF means making sure no non-key attribute is functionally dependent on another non-key attribute. Context. Normalization prevents anomalies such as inconsistent data. DBMS stands for Database Management System, a system software component that manages and controls one or more databases. 4 main components: Application Program Interface, API, Query Interface, Administrative Interface, an underlying set of data access programs and subroutines. Examples. Microsoft SQL Server, Oracle, MySQL. Context. A key distinction is the difference between the DB, database, which is the data itself, and the DBMS, which provides the tools for interacting with the data. Most DBMSs in use today are for relational databases. Deployment. Putting the system or subsystems into use. Direct, parallel, phased deployment. Examples. Installing a new accounting system on servers for users to begin working with as of the start of a new fiscal year. Context. Important issues to consider when planning deployment include incurring costs of operating both systems in parallel, detecting and correcting errors in the new system, potentially disrupting the company and its operations, training personnel and familiarizing customers with new procedures. Design patterns. Standard design techniques and templates that are widely recognized as good practice. Template for OOP. Developed by Goff. 5 elements: pattern name, problem, solution, example, benefits, and consequences. Examples. Controller, handle communication between a domain class, the model, and the boundary class. The view. Observer, allow subscribers to be notified of events occurring within a subject. Singleton allow only a single global instance of a class. Adapter abstract away the connection details between natively incompatible classes. Factory ensure only one instance of utility class. Context. Design patterns allow designers to avoid reinventing the wheel to solve problems that are already well explored. They also provide a shorthand for communicating with developers when describing certain classes, particularly utility classes. Dialogue metaphor. Type of metaphor for human-computer interaction. Interaction which user and computer accomplish a task by engaging in a conversation or dialogue via text, voice, or tools such as labeled buttons. Examples. A pop-up when closing a browser with multiple tabs confirming that you want to close all tabs. The pop-up window asks whether you wish to continue or not. Siri on the Apple iPhone responds to spoken requests to open applications, play music, or search the web. If more information is needed, such as when scheduling a new appointment, Siri asks follow-up questions. Context. Conversation and dialogue are fundamental and universal human skills. Modeling the interaction between user and computer as ideologue enables the user to incorporate language and related skills that have been honed from an early age. Digital signature. A technique in which a document is encrypted by using a private key to verify who wrote the document. Examples. The new Privacy Guard is a free software implementation of OpenPGP that can be used to digitally sign an email before sending. Context. One of the downsides about communication over the Internet is handling authenticity. That is, being sure that the entity you're communicating with is who they say they are. A digital signature provides recipients some assurance that whatever they're receiving indeed came from the source they expected. Encryption/decryption. Encryption. The process of altering data so unauthorized users can't view them. Decryption. The process of converting encrypted data back to their original state. An encryption algorithm, which is a complex mathematical transformation, is used to encrypt or decrypt binary data. An encryption key is a binary input to the encryption algorithm, typically a long string of bits. Examples. When you sign into a secure website, such as for online banking, the information is first encrypted before sending, then decrypted upon receipt. This prevents any interceptors from viewing the content of the information. Context. Encryption/decryption is critical for Internet communications, since by definition information is transmitted through the wild across many networks. Indicer are people who use the system from day to day to achieve the system's business purpose. Training emphasizes hands-on use of the system. Examples. People who log on to Gmail to send and receive their email. Context. One of the most important stakeholder groups for a system because they have to live with it. A system that fails to consider the needs of end users could end up causing more work for an organization than it saves in automation. Event. Something that occurs at a specific time and place, can be precisely identified, and must be remembered by the system. 3 types. External, an event that occurs outside the system, usually initiated by an external agent/actor. Temporal, an event that occurs as a result of reaching a point in time. State, an event that occurs when something happens inside the system that triggers some process. Examples. Customer pays a bill, external event. Customer changes address, external event. Time to send out monthly statements, temporal event. Time to send late notices, temporal event. Inventory stock drops below reorder point, state event. Context. Event decomposition technique is used by analysts to identify use cases by determining the external business events to which the system must respond. An event often triggers an elementary business process, which comprises the most fundamental tasks that leave the system in acquiescent state and is usually performed by one person. HCI. Human-computer interaction. Direct manipulation metaphor, desktop metaphor, document metaphor, and dialogue metaphor. Examples: controls, menus, buttons, pull-down lists, sliders, text entry boxes. Affordance, undo button in Microsoft Word looks like an arrow circling backward, i.e. left, suggesting that it has to do with going back. Visibility, clicking the speaker button on a media player to mute the audio results in the speaker button having ARD prohibition sign overlay, indicating that the speaker is no longer in use. Context includes the concepts of affordance, which is when the appearance of a specific control suggests its function, and visibility, which is when a control is visible to the user and provides immediate feedback to indicate that it's responding to the user. Integrity controls. A control that rejects invalid data inputs, prevents unauthorized data outputs, and protects data and programs against accidental or malicious tampering. Integrated into the application programs that are being developed and the database that supports them. Examples: input controls, value limit controls, completeness controls, data validation controls, field combination controls, processing controls, OS controls, access controls, authentication and authorization, database controls, transaction logging, complex updates, transactions, data integrity, referential integrity, redundancy, backup and recovery, encryption, symmetric key, asymmetric key. Output controls physical access to output, discarded output, access controls to produce output, formatting, and labeling. Context. The primary objectives of integrity controls are to ensure that only appropriate and correct business transactions occur. Ensure that the transactions are recorded and processed correctly. Protect and safeguard the assets of the organization, hardware, software, and information. Object. A structure that encapsulates, packages, attributes, characteristics, and methods, actions, that operate on those attributes. Alt. An abstraction of a real-world thing in which data and processes are packaged together to model the structure and behavior of the real-world object. Examples: an object is an entity with a well-defined role in the context of the application being studied. Concepts or events, department, registration, tangible or visible entity, person, place, or thing, or an artifact of the design process, user interface, controller, scheduler. Context. Objects are the subject and tool of object-oriented analysis and design, OOA&D. Objects usually correspond to the real things an information system deals with: customers, suppliers, contracts, inventory items, etc. Objects facilitate reusability, which improves productivity and system quality. Because an object encapsulates both data and behavior, the object-oriented approach can be used for both process and data modeling. Object-oriented design. Defining all of the types of objects necessary to communicate with people and devices in the system. Showing how objects interact to complete tasks, and refining the definition of each type of object so it can be implemented with a specific language or environment. Examples: design class diagram, sequence diagram, component diagram, communication diagram. Context. The object-oriented approach views an information system as a collection of interacting objects that work together to accomplish tasks. It includes object-oriented analysis, object-oriented design, and object-oriented programming. Design bridges the gap between analysis and programming. Model. Representation of some part of a system. Analysis and design models differ. Examples: graphical analysis, use case diagram, domain model class diagram, system sequence diagram, activity diagram, design class diagram, component diagram, sequence diagram, communication diagram, textual, use case description, event list, mathematical, formulation of how a plane's aerodynamic characteristics might be. Context. Analysts build models to describe system requirements and with users and designers. Reasons for modeling include learning from the modeling process, reducing complexity abstraction, remembering all details. Use those models to communicate. Communicating with other development team members. Communicating with a variety of users and stakeholders. Documenting what was done for future maintenance/enhancement. Pair programming. Extreme programming, XP, practice with 12 programmers work together on designing, coding and testing software. Quality of coding is always higher in this environment. Examples: one programmer writes the code to implement a function while the other reviews the code, making suggestions for improving efficiency or asking questions about why the problem is being addressed in a particular way. Context. The quality of coding is higher because there are always two brains examining the code being produced. The two programmers trade off coding and design responsibilities, testing and reviewing each other's code as it's written. The result is that it takes longer to implement the code, but by the time it's done, it's been designed, coded, reviewed, and tested. Perfect technology assumption states that events should be included during system analysis only if the system would be required to respond under perfect conditions. Equipment never breaking down. Capacity for processing and storage unlimited. People operating the system completely honest and never making mistakes. Examples: events and use cases compiled during analysis omit system controls such as login, logout, or change password. Context. This assumption is useful in both the analysis phase and the design phase. In the analysis phase, it allows the analyst to focus on business needs rather than compensating for design flaws. In the design phase, it allows the designer to begin with a simpler model before layering in additional complexity to handle exception conditions. Relational database. A database that stores information in tables or relations. Tables are linked together through primary and foreign keys. Examples: Microsoft Access is used to create relational databases. Most databases in use today are relational databases. Context. A high-quality relational database has these features: flexibility or ease of implementing future data model changes. Lack of redundant data. Project. A project is a planned undertaking with a beginning and an end, which produces a predetermined result and is usually constrained by a schedule and resources. Examples: the case study to build a car-sharing information system is a project. Building a new customer relationship management system. Replacing an aging billing system with new commercial software. Context. Projects can be very formal, or so informal that they can barely be recognized as projects. The core processes involved in managing a project are: identify problem and obtain approval, plan and monitor the project, discover and understand the details, design system components, build, test, and integrate system components, complete system tests and deploy solution. Strong project management is seen as one factor that improves success rates of software development projects. Requirements. All the activities the new system must perform or support and the constraints that the new system must meet. System requirements include the functions the system must perform, functional requirements, and such related issues, such as user interface formats and requirements for reliability, performance, and security, non-functional requirements. Examples: generate electronic funds transfers, calculate commission amounts, calculate payroll taxes, maintain employee-dependent information, report tax deductions to the IRS. Context: most of the analyst's time is devoted to requirements, gathering information about them, formalizing them by using models and prototypes, refining and expanding them, prioritizing them, and generating and evaluating alternatives. What is important is that all requirements be identified and precisely stated early in the development process, and that inconsistencies or trade-offs among them be resolved. Requirements determination. FERPS, Requirements Classification Framework acronym, stands for functionality, usability, reliability, performance and security. Examples: functions generate electronic funds transfers, usability menu format, color schemes, multilingual support, reliability how often outages occur, performance 100 simultaneous client sessions, with 500 milliseconds response time, security password protection, encrypt locally stored data with 10 24-bit keys. Plus, design constraints must use the Android OS. Implementation must be written in the Clojure programming language. Interface must generate data for the SEC in specific XML format. Physical must weigh less than 200 grams. Support download and install updates automatically. Context: the analyst uses information gathered from users and documents to define requirements for the new system. The analyst creates models to record requirements, reviews the models with users and others, and refines and expands the models to reflect new or updated information. Scrum, adaptive software development methodology. The objective is to be quick, agile, intense, and goes full distance. Basic control mechanism is the product backlog. Organizational elements are product owner, Scrum Master, Scrum Team. 30-day Scrum Sprint. Examples: product owner manages the product, Scrum Master manages the process, Scrum Team manages itself. Sprint planning meeting, daily Scrum meeting, end of sprint review meeting. Context: the Scrum philosophy is based on the Agile development principles. It excels in situations in which users might not know exactly what is needed and might also change priorities frequently. It is a type of social engineering that emphasizes individuals more than processes and describes how teams of developers can work together. SDLC, Systems Development Life Cycle. The entire process consisting of all the activities required to build, launch, and maintain an information system. 6 core processes: identify problem and obtain approval, plan and monitor project, discover and understand the details, design system components, build, test, and integrate system components, complete system tests and deploy solution. Examples: a waterfall approach finishes each core process before moving on the next, referred to as phases. An agile development approach engages in activities from each core process with every iteration. Multiple iterations are required before the project is finished. Context: the SDLC is implemented using an information systems development process. There are many approaches to the SDLC and many variations for projects that have various needs. Security controls. A control that protects the assets of an organization from all threats, with a primary focus on external threats. 2 main objectives: maintain a stable, functioning operating environment for users and application systems. 24/7. Protect info and transactions during transmission across the Internet and other insecure environments. Examples: access control list, ACL, Multi-factor authentication. Password length/complexity policies. Context. The primary focus is on external threats. The most common security control points are network and computer operating systems, because they exercise direct control over such assets as files, application programs, and disk drives. Operating system security is the foundation of security for most information systems. Stakeholders. All persons who have an interest in the successful implementation of the system. Internal versus external. Internal stakeholders are persons within the organization who interact with the system, or have a significant interest in its operation or success. External stakeholders are persons outside the organization's control and influence who interact with the system or have a significant interest in its operation or success. Operational versus executive. Operational stakeholders are persons who regularly interact with a system in the course of their jobs or lives. Executive stakeholders are persons who don't interact directly with the system but who either use information produced by the system or have a significant financial or other interest in its operation and success. End users. Senior managers. Accountants. Customers. Investors. Context. Stakeholders are the primary source of information for system requirements. Each stakeholder group interacts with the system in different ways, and each has a unique perspective on system requirements. System interface. Inputs or outputs that require minimal human interaction. Examples. Scanned inputs captured automatically. Messages to or from another system. Transactions captured by another system. Context. System interfaces are distinct from user interfaces, which more directly involve a system user. System development methodology. A set of comprehensive guidelines for the SDLC that includes specific models, tools, and techniques. See SDLC. Examples. Structured approach. Object-oriented approach. Context. A methodology includes a collection of techniques that are used to complete activities within each phase of the SDLC. The activities include the completion of a variety of models as well as other documents and deliverables. Software tools help to complete the activities. System vision document. A document to help define the scope of a new system. 3 components to this document. Problem description. Anticipated business benefits. System capabilities. Examples. A 1-page summary using bullet points to list benefits and capabilities. Context. Frequently the document is completed in 2 steps. Developing a preliminary statement of benefits. Adding estimates of specific dollar costs and dollar benefits. It is on the basis of this document that a decision is made to move ahead with the project and budget the necessary funds. Top-down vs. Bottom-up development. Top-down development. A development order that implements top-level modules first. Advantage: always a working version of program. Disadvantage: doesn't use programmers efficiently at beginning. Bottom-up development. A development order that implements low-level detailed modules first. Advantage: uses programmers right away. Disadvantage: complex due to several driver classes and test engines delayed until top levels. Done. Examples. Methods in the view layer call methods in the domain layer, which in turn call methods in the data access layer. Top-down would implement the view layer classes and methods first, the domain classes next, and the data access layer classes and methods last. Bottom-up would reverse that order. Context. These terms have their roots in structured development but can also be applied to object-oriented designs and programs. The key issue is dependency, that is, which methods call which other methods. 3-layer client-server architecture. A client/server architecture that divides an application into view layer, business logic layer, and data layer. View layer logic format screens and report. Domain layer logic implement business rules. Data layer logic formulate queries. Examples. Internet deployment. View layer is in the browser and web server. Domain layer is on the application server. Data layer is on the database server. Context. Based on the design principle of object responsibility, it is possible to define which program responsibilities belong to each layer. Following these guidelines will make a system much easier to maintain. Unified process. UP is widely recognized as a highly influential innovation in software development methodologies for OOD using an adaptive approach. 4 UP phases: inception, elaboration, construction, transition. Examples. 6 main disciplines: business modeling, requirements, design, implementation, testing, deployment. 3 support disciplines: configuration and change management, project management, environment. Context. Originally offered by Rational Software, now a part of IBM, UP is now widely recognized as a high influential innovation in software development methodologies. All 9 disciplines are employed throughout the lifetime of a project but to different degrees. UP must be tailored to the development team and the specific project, although it does tend toward more ceremony than other agile methodologies. UML. Unified Modeling Language. Standard set of model constructs and notations defined by the Object Management Group. Examples. Use case diagram, class diagram, sequence diagram, communication diagram, state machine diagram. Context. By using UML, analysts and end users are able to depict and understand a variety of specific diagrams used in a system development project. Prior to UML, there was no standard, so diagrams could be confusing. Diagram. Unit testing. The process of testing individual methods, classes, or components before they are integrated with other software. Goal is to identify and fix as many errors before being combined into larger software units. Utilizes drivers and stubs. Examples. Driver method calls the method login test. Method being tested runs login. Login calls stub methods that return constant data, get user. Context. Errors become much more difficult and expensive to locate and fix when many units are combined. Unit testing can be used to provide immediate feedback for developers and is also used in test-driven development, TDD. Usability test. A test to determine whether a method, class, subsystem or system meets user requirements. Test to see if the system functions as expected. User interface is easy to use. Examples. User logs into the software and tries to enter an order, recording the experience and noting any concerns or errors. Context. Usability tests are conducted frequently, as user interfaces are developed to provide rapid feedback to developers for improving the interface and correcting any errors in the underlying software components. Use case. An activity that the system performs usually in response to a request by user. Use cases determined by 3 techniques. User goal. Event decomposition. CRUD. Examples. Lookup supplier. Enter/update supplier information. Lookup contact. Enter/update contact information. Context. A key early step in the modeling process is to identify and list the use cases that define the functional requirements for the system. Each use case identified by the analyst is further documented by a brief use case description and by identifying the actors. UML use case diagrams are drawn based on the need to review use cases with various stakeholders, users, and team members. Use case serialization. The process of elaborating the detailed design with interaction diagrams for a particular use case. Examples: design class diagrams, sequence diagrams. Context. Detailed design is use case driven in that each use case is designed separately. As part of this process, utility and support classes are identified. Care is taken during this process to maintain the integrity of the multi-layer architectural design. User goal technique. A technique to identify use cases by determining what specific goals or objectives must be accomplished or completed by the user. Focuses on interviewing each type of user to determine what the system needs to do. Examples: user goals for shipping personnel, ship items, track shipment, create item return. Context. The technique includes these steps. 1. Identify all the potential users for the new system. 2. Classify potential users by functional role. 3. Further classify by organizational level. 4. Interview to find a list of user goals. 5. Create preliminary list of use cases. 6. Look for duplicates and resolve inconsistencies. 7. Identify where different users need the same use cases. 8. Review completed list with each type of user, then stakeholders. User interface. System inputs and outputs that more directly involve a system user. It is everything the end user comes into contact with while using the system physically, perceptually and conceptually. Focus should be on user-centered design. Examples: drop-down menu, dialog window, button. Context. To the user of a system, the user interface is the system. Models and tools used to perform user interface design include mock UPS, storyboards, graphical layouts, and prototyping with screen modeling tools. Definitions. Computer application, app. A computer software program that executes on a computing device to carry out a specific function or set of related functions. Information system, a set of interrelated computer components that collects, processes, stores, and provides as output the information needed to complete business tasks. Systems analysis. Those activities that enable a person to understand and specify what the new system should accomplish. Systems design. Those activities that enable a person to define and describe in detail the system that solves the need. Project, a planned undertaking that has a beginning and an end, and that produces some definite result. Systems development life cycle, SDLC. The entire process consisting of all the activities required to build, launch, and maintain an information system. Information systems development process, the actual approach used to develop a particular information system. Agile development, an information systems development process that emphasizes flexibility to anticipate new requirements during development. Iterative development, an approach to system development in which the system is grown piece by piece through multiple iterations. Subsystem, an identifiable and partitioned portion of an overall system. Predictive approach to the SDLC, an approach that assumes the project can be planned in advance and that the new information system can be developed according to the plan. Adaptive approach to the SDLC, an approach that assumes the project must be more flexible and adapt to changing needs as the project progresses. Phases, related groups of development activities, such as planning, analysis, design, implementation, and support. Waterfall model, an SDLC approach that assumes the phases can be completed sequentially. Spiral model, an adaptive SDLC approach that cycles over and over again through development activities until completion. Incremental development, an SDLC approach that completes portions of the system in small increments across iterations, with each increment being integrated into the whole as it is completed. Walking skeleton, a development approach in which the complete system structure is built with bare-bones functionality. Support activities, the activities in the support phase whose objective is to maintain and enhance the system after it is installed and in use. Help desk, the availability of support staff to assist users with technical or processing problems of the information system. System development methodology, a set of comprehensive guidelines for the SDLC that includes specific models, tools, and techniques. Tool, a software application that assists developers in creating models or other components required for a project. Integrated development environments, IDEs, a set of tools that work together to provide a comprehensive development and programming environments for software developers. Visual modeling tools, tools that help analysts create and verify graphical models and may also generate program code. Technique, guidelines to specify a method for how to carry out a development activity or task. Structure approach, system development using structured analysis, structured design, and structured programming techniques. Structured programming, a programming approach where each model has one start point and one end point and uses sequence, decision, and repetition constructs only. Top-down programming, the concept of dividing a complex program into a hierarchy of program modules. Structured design, the design process of organizing a program into a set of modules and organizing those modules into a hierarchical structure. Structure chart, a graphical diagram showing the hierarchical organization of modules. Structured analysis, a technique to determine what processing is required and to organize those requirements by using structured analysis models. Data flow diagram, DFD, a structured analysis model showing inputs, processes, storage, and outputs of a system. Object-oriented approach, system development based on the view that a system is a set of interacting objects that work together. Object, a thing in an information system that responds to messages by executing functions or methods. Object-oriented analysis, OOA, the process of identifying and defining the use cases and the sets of objects, classes, in the new system. Object-oriented design, OOD, defining all of the types of objects necessary to communicate with people and devices in the system, showing how objects interact to complete tasks, and refining the definition of each type of object so it can be implemented with a specific language or environment. Object-oriented programming, OOP, programming using object-oriented languages that support object classes, inheritance, reuse, and encapsulation. Agile development, a guiding philosophy and set of guidelines for developing information systems in an unknown, rapidly changing environment. Chaotic, a term used to describe adaptive projects that are chaotic and ordered. Agile modeling, a guiding philosophy in which only models that are necessary, with a valid need and at the right level of detail, are created. Project management, organizing and directing other people to achieve a planned result with a predetermined schedule and budget. Client, the person or group that funds the project. Oversight committee, clients and key managers who review the progress and direct the project. Users, the person or group of people who will use the new system. Ceremony, the level of formality of a project, the rigor of holding meetings and producing documentation. Project management body of knowledge, PMBOK, a project management guide and standard of fundamental project management principles. System vision document, a document to help define the scope of a new system. Business benefits, the benefits that accrue to the organization usually measured in dollars. System capabilities, the required capabilities of a new system, part of a system vision. Document. Cost/benefit analysis, process of comparing costs and benefits to see whether investing in a new system will be beneficial. Net present value, NPV, the present value of dollar benefits and dollar costs of a particular investment. Break-even point, the point in time at which dollar benefits offset dollar costs. Payback period, the time period after which the dollar benefits have offset the dollar costs. Tangible benefit, a benefit that can be measured or estimated in terms of dollars. Intangible benefit, a benefit that accrues to an organization but that can't be measured quantitatively or estimated accurately. Project iteration schedule, the list of iterations and use cases or user stories assigned to each iteration. Detailed work schedule, the schedule that lists, organizes, and describes the dependencies of the detailed work tasks. Work breakdown structure, WBS, the list or hierarchy of activities and tasks of a project, used to estimate the work to be done and to create a detailed work schedule. Gantt chart, a bar chart that portrays the schedule by the length of horizontal bars superimposed on a calendar. Critical path, a sequence of tasks that can't be delayed without causing the entire project to be delayed. Retrospective, a meeting held by the team at the end of an iteration to determine what was successful and what can be improved. Technology architecture, a set of computing hardware, network hardware, and topology, and system software employed by an organization. Application architecture, the organization and construction of software resources to implement an organization's information systems. System requirements, the activities a system must perform or support and the constraints that the system must meet. Functional requirements, the activities that the system must perform. Non-functional requirements, system characteristics other than the activities it must perform or support. FERPS, a requirements classification framework, acronym stands for functionality, usability, reliability, performance, and security. Usability requirements, operational characteristics related to users, such as the user interface, related work procedures, online help, and documentation. Reliability requirements, requirements that describe system dependability. Performance requirements, operational characteristics related to measures of workload, such as throughput and response time. Security requirements, requirements that describe how access the application will be controlled and how data will be protected during storage and transmission. FERPS Plus, an extension of FERPS that includes design constraints as well as implementation. Interface, physical, and supportability requirements. Design constraints, restrictions to which the hardware and software must adhere. Implementation requirements, constraints such as required programming languages and tools, documentation method and level of detail, and a specific communication protocol for distributed components. Interface requirements, required interactions among systems. Physical requirements, characteristics of hardware such as size, weight, power consumption, and operation conditions. Supportability requirements, how a system is installed, configured, monitored, and updated. Model, representation of some aspect of a system. Textual models, text-based models such as memos, reports, narratives, and lists. Graphical models, system models that use pictures and other graphical elements. Mathematical models, system models that describe requirements numerically or as mathematical expressions. Unified Modeling Language, UML standard set of model constructs and notations defined by stakeholders, persons who have an interest in the successful implementation of the system. Internal stakeholders, persons within the organization who interact with the system or have a significant interest in its operation or success. External stakeholders, persons outside the organization's control and influence who interact with the system or have a significant interest in its operation or success. Operational stakeholders, persons who regularly interact with a system in the course of their jobs or lives. Executive stakeholders, persons who don't interact directly with the system but who either use information produced by the system or have a significant financial or other interest in its Operation and success. Client. Person or group that provides the funding for a system development project. Open-ended questions, questions that encourage discussion or explanation. Closed-ended questions, questions that elicit specific facts. Workflow, sequence of processing steps that completely handles one business transaction or customer request. Activity diagram, describes uses, or system, activities, the person who does each activity, and the sequential flow of these activities. Synchronization bar, activity diagram component that either splits a control path into multiple concurrent paths or recombines concurrent paths. Swim lane heading, activity diagram column containing all activities for a single agent or organization unit. Use case, an activity that the system performs, usually in response to a request by a user. User goal technique, a technique to identify use cases by determining what specific goals or objectives must be completed by a user. Event decomposition technique, a technique to identify use cases by determining the external business events to which the system must respond. Elementary business processes, EBPs, the most fundamental tasks in a business process, which leaves the system and data in a quiescent state, usually performed by one person in response to a business event. Event, something that occurs at a specific time and place, can be precisely identified, and must be remembered by the system. External event, an event that occurs outside the system, usually initiated by an external agent. Actor, an external agent, a person or group that interacts with the system by supplying or receiving data. Temporal event, an event that occurs as a result of reaching a point in time. State event, an event that occurs when something happens inside the system that triggers some process. System controls, checks or safety procedures to protect the integrity of the system and the data. Perfect technology assumption, the assumption that a system runs under perfect operating and technological conditions. CRUD technique, an acronym for create, read/report, update, and delete, a technique to validate or refine use cases. Brief use case description, an often one-sentence description that provides a quick overview of a use case. Use case diagram, the UML model used to graphically show use cases and their relationships to actors. Automation boundary, the boundary between the computerized portion of the application and the users who operate the application but are part of the total system. Relationship, a relationship between use cases in which one use case is stereotypically included within the other use case. Problem domain, the specific area, or domain, of the user's business need, or problem, that is within the scope of the new system. Brainstorming technique, a technique to identify problem domain objects in which developers work with users in an open group setting. Noun technique, a technique to identify problem domain objects by finding and classifying the nouns in a dialogue or description. Attributes, descriptive pieces of information about things or objects. Identifier or key, an attribute the value of which uniquely identifies an individual thing or object. Compound attribute, an attribute that consists of multiple pieces of information but is best treated in the aggregate. Association, a term, in UML, that describes a naturally occurring relationship between specific relationship, a term that describes a naturally occurring association between specific things. Sometimes called an association. Cardinality, a measure of the number of links between one object and another object in a multiplicity, a measure, in UML, of the number of links between one object and another object. In an association. Multiplicity constraints, the actual numeric count of the constraints on objects allowed in an association. Binary associations, associations between exactly two distinctive things. Unary association, an association between two instances of the same type of thing. Ternary association, an association between exactly three distinct types of things. N-ary association, an association between n distinct types of things. Data entities, the term used in an ER diagram to describe sets of things or individual things. Entity relationship diagram, ERDA diagram consisting of data entities, i.e. sets of things, and their relationships. Semantic net, a graphical representation of an individual data entity and its relationship with other individual data entities. Class, a category or classification of a set of objects or things. Domain classes, classes that describe objects from the problem domain. Class diagram, a diagram consisting of classes, i.e. sets of objects, and associations among the classes. Domain model class diagram, a class diagram that only includes classes from the problem domain. Camelback notation or camel case notation, when words are concatenated to form a single word and the first letter of each embedded word is capitalized. Association class, an association that is also treated as a class, often required in order to capture attributes for the association. Generalization/specialization relationship, a type of hierarchical relationship in which subordinate classes are subsets of objects of the superior classes, an inheritance hierarchy. Subclass, a subordinate or more specialized class in a generalization/specialization. Inheritance, the concept that specialization classes inherit the attributes of the generalization class. Abstract class, a class that describes a category or set of objects but that never includes individual objects or instances. Concrete class, a class that allows individual objects or instances to exist. Whole-part relationship, a relationship between classes in which one class is a part or a component portion of another class. Aggregation, a type of whole-part relationship in which the component parts also exist as individual objects apart from the aggregate. Composition, a type of whole-part relationship in which the component parts cannot exist as individual objects apart from the total composition. Use case description, a textual model that lists and describes the processing details for a use case. Scenarios or use case instances, unique sets of internal activities within use cases. Precondition, a condition that must be true before a use case begins. Postcondition, what must be true upon the successful completion of a use case. System sequence diagram, SSDA diagram showing the sequence of messages between an external actor and the system during a use case or scenario. Interaction diagram, either a communication diagram or a sequence diagram that shows the interactions between objects. Lifeline or object lifeline, the vertical line under an object on a sequence diagram to show the passage of time for the object. Loop frame, notation on a sequence diagram showing repeating messages. True/false condition, part of a message between objects that is evaluated prior to transmission to determine whether the message can be sent. Opt frame, notation on a sequence diagram showing optional messages. Alt frame, notation on a sequence diagram showing if-then-else logic. State, a condition during an object's life when it satisfies some criterion, performs some action, or waits for an event. Transition, the movement of an object from one state to another state. State machine diagram, a diagram showing the life of an object in states and transitions. Pseudostate, the starting point of a state machine diagram, indicated by a black dot. Destination state, for a particular transition, the state to which an object moves after the completion of a transition. Origin state, for a particular transition, the original state of an object from which the transition occurs. Action expression, a description of the activities performed as part of a transition. Guard condition, a true/false test to see whether a transition can fire. Concurrency or concurrent state, the condition of being more than one state at a time. Path, a sequential set of connected states and transitions. Composite state, a state containing other states and transitions, that is, a path. Network diagram, a model that shows how the application is deployed across networks and computers. Architectural design, broad design of the overall system structure, also called general design or conceptual design. Detail design, low-level design that includes the design of the specific program details. Local area network, LAN, a computer network in which the cabling and hardware are confined to a single location. Client-server architecture, a computer network configuration with users' computers and central computers that provide common services. Client computers, the computers at which the users work to perform their computational tasks. Server computer, the central computer that provides services, such as database access, to the client computers over a network. Hypertext markup language, HTML, the predominant language for constructing web pages, and which consists of tags and rules about how to display pages. Transmission Control Protocol / Internet Protocol, TCP/IP, the foundation protocol of the Internet, used to provide reliable delivery of messages between networked computers. Three-layer architecture, a client/server architecture that divides an application into view layer, business logic layer, and data layer. View layer, the part of the three-layer architecture that contains the user interface. Business logic layer or domain layer, the part of a three-layer architecture that contains the programs that implement the business rules and processes. Data layer, the part of a three-layer architecture that interacts with the data. Hypertext Transfer Protocol, secure, HTTPS, an encrypted form of information transfer on the Internet that combines HTTP and TLS. Transport Layer Security, TLS, an advanced version of Secure Sockets Layer, SSL, protocol, used to transmit information over the Internet securely. Content Delivery Network, CDN, a set of server computers, separate from the hosting computers, used to deliver such static content as images or videos. Hosting, the process of providing physical servers at a secure location and selling those services to other businesses that wish to deploy websites. Co-location, a hosting service with a secure location but in which the computers are usually owned by the client businesses. Virtual server, a method to partition the services of a physical web server so it appears as multiple, independent Internet servers. Cloud computing, an extension of virtual servers in which the resources available include computing, storage, and Internet access and appear to have unlimited availability. Service Level Agreement, SLA, part of the contract between a business and a hosting company that guarantees a specific level of system availability. Virtual Private Networks, VPNs, a closed network with security and closed access built on top of a public network, such as the Internet. Peer-to-peer connection, when independent computers communication and share resources without the need of a centralized server computer. System interfaces, inputs or outputs that require minimal human intervention. User interfaces, system interfaces that directly involve a system user. User-centered design, design techniques that embody the view that the user interface is the entire system. Usability, degree to which a system is easy to learn and use. Metaphors, analogies between features of the user interface and aspects of physical reality that users are familiar with. Direct manipulation metaphor, metaphor in which objects on a display are manipulated to look like physical objects, pictures, or graphic symbols that represent them, icons. Desktop metaphor, metaphor in which the visual display is organized into distinct regions, with a large empty workspace in the middle and a collection of tool icons around the perimeter. Document metaphor, metaphor is which data is visually represented as paper pages or forms. Dialogue metaphor, metaphor in which user and computer accomplish a task by engaging in a conversion or dialogue via text, voice, or tools such as labeled buttons. Human-computer interaction, HCI field of study concerned with the efficiency and effectiveness of user interfaces vis-a-vis computer systems, human-oriented input and output, technology, and psychological aspects of user interfaces. Affordance, when the appearance of a specific control suggests its function. Visibility, when a control is visible so that users know it is available, the control providing immediate feedback to indicate that it is responding to the user. Storyboarding, sequence of sketches of the display screen during a dialogue. Text box, a rectangular box that accepts text types on a keyboard of recognized from speech input. List box, a text box that contains a list of predefined data values. Combo box, a text box that contains a predefined list of acceptable entries but permits the user to enter a new value when the list doesn't contain the desired value. Radio buttons, a group of choices from which the user selects only one, the system then. Cascading style sheets, CSS web page encoding standard that enables a website designer to specify parts of a page that will always look the same and parts that will vary by task or audience. Assistive technologies. Software, such as text-to-speech and voice recognition utilities, that adapts user interfaces to the special needs of persons with disabilities. Extensible markup language, XML extension of HTML that embeds self-defining data structures within textual messages. XML tags, character sequences, such as, and, that define the beginning, end, and meaning of the text that appears between them. Detailed reports, reports that contain specific information on business transactions. Summary reports, reports that summarize detail or recap periodic activity. Exception reports, reports that provide details or summary information about transactions or operating results that fall outside a predefined normal range of values. Executive reports, reports used by high-level managers to assess overall organizational health and performance. Internal outputs, reports or other outputs produced for use within the organization. External outputs, reports or other outputs produced for use by people outside the organization. Turnaround documents, external outputs that includes one or more parts intended to be returned with new data or information. Drill down, user interface design technique that enables a user to select summary information and view supporting detail. Instantiation, creation of an object based on the template provided by the class definition. Enterprise-level system, a system that has shared resources among multiple people or groups in an organization. Component diagram, a type of implementation diagram that shows the overall system architecture and the logical components within it. Application Program Interface, API, the set of public methods that are available to the outside world. Stereotype, a way of categorizing a model element by its characteristics, indicated by Guillemets. Entity class, a design identifier for a problem domain class. Persistent class, an entity class whose objects exist after a system is shut down. Boundary class or view class, a class that exists on a system's automation boundary, such as an input window. Control class, a class that mediates between boundary classes and entity classes, acting as a switchboard between the view layer and domain layer. Data access class, a class that is used to retrieve data from and send data to a database. Visibility, a notation that indicates, by plus or minus sign, whether an attribute can be directly accessed by another object. Method signature, a notation that shows all the information needed to invoke, or call, the method. Class level method, a method that is associated with a class instead of with objects of the class. Class level attribute, an attribute that contains the same value for all objects in the system. Abstract class, a class that can never be instantiated, no objects can be created of this type. Concrete class, a class that can be instantiated, objects can be created of this type. Navigation visibility, a design principle in which one object has a reference to another object, and thus can interact with it. CRC cards, a brainstorming technique for designing interactions and use cases by assigning responsibilities and collaborations for classes. Coupling, a qualitative measure of how closely the classes in a design class diagram are linked. Cohesion, a qualitative measure of the focus or unity of purpose within a single class. Protection from variations, a design principle in which parts of a system that are unlikely to change are segregated from those that will. Indirection, a design principle in which an intermediate class is placed between two classes to decouple them but still link them. Object responsibility, a design principle in which objects are responsible for carrying out system processing. Use case realization, the process of elaborating the detailed design with interaction diagrams for a particular use case. Design patterns, standard design techniques and templates that are widely recognized as good practice. Sequence diagrams, type of interaction diagram that emphasizes the sequence of messages sent between objects for a specific use case. Communications diagrams, type of interaction diagram that emphasizes the objects that send and receive messages for a specific use case. Activation lifeline, a representation of the period during which a method of an object is alive and executing. Separation of responsibilities, a design principle that recommends segregating classes into separate components based on the primary focus of the classes. Persistent classes, problem domain classes that must be remembered between program executions, i.e. require storage in a database. Dependency relationship, a relationship between packages, classes, or use cases in which a change in the independent item requires a change in the dependent item. Database, DB, an integrated collection of stored data that is centrally managed and controlled. Database management system, DBMS, a system software component that manages and controls one or more databases. Physical data store, database component that stores the raw bits and bytes of data. Schema, database component that contains descriptive information about the data stored in the physical data store. Relational database management system, RDBMS, a DBMS that organizes data in tables or relations. Table, a two-dimensional data structure of columns and rows. Row, one horizontal group of data attribute values in a table. Attribute, one vertical group of data attribute values in a table. Attribute value, the value held in a single table cell. Key, an attribute or set of attributes, the values of which occur only once in all the rows of the table. Primary key, the key chosen by a database designer to represent relationships among rows in different tables. Foreign key, an attribute that duplicates the primary key of a different, or foreign, table. Referential integrity, a consistent state among foreign key and primary key values. Referential integrity constraint, a constraint, stored in the schema, that the DBMS uses to automatically enforce referential integrity. Normalization, a formal technique for evaluating and improving the quality of a relational database schema. First normal form, 1NF restriction that all rows of a table must contain the same number of columns. Functional dependency, a one-to-one association between the values of two attributes. Second normal form, 2NF restriction that a table is in 1NF and that each non-key attribute is functionally dependent on the entire primary key. Third normal form, 3NF restriction that a table is in 2NF and that no non-key attribute is functionally dependent on any other non-key attribute. Data type, the storage format and allowable content of a program variable, class attribute, or relational database attribute or column. Primitive data type, a data type supported directly by computer hardware or a programming language. Complex data type, combinations of or extensions to primitive data types that are supported by programming languages, operating systems, and DBMSs. Single database server architecture, one or more databases are hosted by a single DBMS, running on a single server. Replicated database server architecture, complete database copies are hosted by cooperating DBMSs running on multiple servers. Partitioned database server architecture, multiple distributed database servers are used and the database schema is partitioned, with some content on only one server and some content copied on all servers. Cloud-based database server architecture, use of a cloud computing service provider to provide some or all database services. Database synchronization, updating one database copy with changes made to other database copies. Integrity control, a control that rejects invalid data inputs, prevents unauthorized data outputs, and protects data and programs against accidental or malicious tampering. Input control, a control that prevents invalid or erroneous data from entering the system. Value limit control, a control that checks numeric data input to ensure that the value is reasonable. Completeness control, a control that ensures that all required data values describing an object or transaction are present. Data validation control, a control that ensures that numeric fields that contain codes or identifiers are correct. Field combination control, a control that reviews combinations of data inputs to ensure that the correct data are entered. Access control, a control that restricts which persons or programs can add, modify, or view information resources. Transaction logging, a technique by which any updates to the database is logged with such audit information as user ID, data, time, input data, and type of update. Complex update control, a control that prevents errors that can occur when multiple programs try to update the same data at the same time or when recording a single transaction requires multiple related database updates. Output control, a control that ensures that output arrives at the proper destination and is accurate, current, and complete. Fraud triangle, model of fraud that states that opportunity, motivation, and rationalization must all exist for a fraud to occur. Security control, a control that protects the assets of an organization from all threats, with a primary focus on external threats. Authentication, the process of identifying users who request access to sensitive resources. Multi-factor authentication, using multiple authentication methods for increased reliability. Access control list, a list attached or linked to a specific resource that describes users or user groups and the nature of permitted access. Authorization, the process of allowing or restricting a specific authentication user's access to a specific resource based on an access control list. Unauthorized user, a person who isn't allowed access to any part or functions of the system. Registered user, a person who is authorized to access the system. Privileged user, a person who has access to the source code, executable program, and database structure of the system. Encryption, the process of altering data so unauthorized users can't view them. Decryption, the process of converting encrypted data back to their original state. Encryption algorithm, a complex mathematical transformation that encrypts or decrypts binary data. Encryption key, a binary input to the encryption algorithm, typically a long string of bits. Symmetric key encryption, encryption method that uses the same key to encrypt and decrypt the data. Remote wipe, security measure that automatically deletes sensitive data from a portable device when unauthorized accesses are attempted. Asymmetric key encryption, encryption method that uses different keys to encrypt and decrypt the data. Public key encryption, a form of asymmetric key encryption that uses a public key for encryption and a private key for decryption. Digital signature, a technique in which a document is encrypted by using a private key to verify who wrote the document. Digital certificate, an institution's name and public key, plus other information, such as address, website URL, and validity date of the certificate, encrypted and certified by a third party. Certifying authority, a widely accepted issuer of digital certificates. Secure sockets layer, SSL, a standard set of methods and protocols that address authentication, authorization, privacy, and integrity. Transport layer security, TLS, an internet standard equivalent to SSL. IP security, IPsec, an internet standard for secure transmission of low-level network packets. Secure hypertext transport protocol, HTTPS, an internet standard for securely transmitting web pages. Test case, a formal description of a starting state, one or more events to which the software must respond, and the expected response or ending state. Test data, a set of starting states and events used to test a module, group of modules, or entire system. Unit test, test of an individual method, class, or component before it is integrated with other software. Driver, a method or class developed for unit testing that simulates the behavior of a method that sends a message to the method being tested. Stub, a method or class developed for unit testing that simulates the behavior of a method that hasn't yet been written. Integration test, test of the behavior of a group of methods, classes, or components. Usability test, a test to determine whether a method, class, subsystem, or system meets user requirements. System test, an integration test of an entire system or independent subsystem. Build and smoke test, a system test that is performed daily or several times a week. Performance test or stress test, an integration and usability test that determines whether a system or subsystem can meet time-based performance criteria. Response time, for desired or maximum allowable time limit for software response to a query or update. Throughput, the desired or minimum number of queries and transactions that must be processed per minute or hour. User acceptance test, a system test performed to determine whether the system fulfills user requirements. System documentation, descriptions of system requirements, architecture, and construction details, as used by maintenance personnel and future developers. User documentation, descriptions of how to interact with and use the system, as used by end users and system operators. Input, process, output, IPO, development order, a development order that implements input modules first, process modules next, and output modules last. Top-down development, a development order that implements top-level modules first. Bottom-up development, a development order that implements low-level detailed modules first. Source Code Control System, SCCS, an automated tool for tracking source code files and controlling changes to those files. Direct deployment or immediate cutover, a deployment method that installs a new system, quickly makes it operational, and immediately turns off any overlapping systems. Parallel deployment, a deployment method that operates the old and the new systems for an extended time period. Phased deployment, a deployment method that installs a new system and makes it operational in a series of steps or phases. Alpha version, a test version that is incomplete but ready for some level of rigorous integration or usability testing. Beta version, a test version that is stable enough to be tested by end users over an extended period of time. Production, release, release version, or production release, a system version that is formally distributed to users or made operational for long-term use. Maintenance release, a system update that provides bug fixes and small changes to existing features. Production system, the version of the system used from day to day. Test system, a copy of the production system that is modified to test changes. UP discipline, a set of functionally related activities that combine to enable the development process in a UP project. Pair programming, XP practice in which two programmers work together on designing, coding, and testing software. Refactoring, revising, reorganizing, and rebuilding part of a system so it is of higher quality. Product backlog, a prioritized list of user requirements used to choose work to be done in a Scrum project. Product owner, the client stakeholder to whom the system is being built. Scrum master, the person in charge of a Scrum project, similar to a project manager. Sprint, a time-controlled mini-project that implements a specific portion of a system. Device-top application, a computer application that is built to execute on a local computer, such as a desktop, without requiring a client/server connection. Freestanding Internet application, a client/server application that is self-contained and doesn't require the use of a web browser. Browser-based application, a client/server application that executes locally within the control of a web browser. Internet backbone, the primary data routes between large, strategically interconnected networks and routers on the Internet. Last mile, the final leg that delivers connectivity from the Internet network to the customer. Software as a service, SaaS, a software delivery model similar to a utility, in which the application and its associated data are accessed via the Internet without locally installed programs. On-demand software, another term for SaaS. Open source software, a method of developing, delivering, and licensing software that makes the application source code freely available to any interested developer or client. Web 2.0, a loosely defined, non-standard term used to refer to websites that permit user-generated content and user interaction, such as social networking sites. Plugins, a software component that adds specific capabilities to a larger software application. Widget, a type of plugin that focuses on enhancing the user interface with additional capability. Theme, a type of add-on to an application that allows the look and feel, such as colors and layout, to be changed. Toolbar, a type of add-on usually comprised of iconic menu that access the capabilities of the application or plugins in a user-friendly fashion. Web Mini App, a software application that provides a complete set of functions but that must be executed within the confines of another application. Mashup, a type of website that combines the functionality of several other websites through the use of predefined APIs. Rich Internet Applications, RIAS, a type of website that provides active user interaction as well as delivers rich multimedia. HTML5, the new HTML specification that standardizes RIA specifications for built-in browser delivery.